Hi guys, today we're going to be looking at questions revolving around negative indices, and these first few questions begin relatively easy, but they will start to get a little bit more difficult. What I'm going to get you to do to start these questions is just try these on your calculator, and you'll notice that you actually get a different answer. So I'm going to give you a second maybe to pause the video and just try that. All right, so hopefully you've paused the video and you've attempted these on your calculator, and what you'll find is that the answer to this will be -9, and the answer to this will be +9. And the reason why that is because whenever we multiply a base by itself, if it's got a negative, multiplying two negatives together will actually give us a positive answer. Right, so in a way, you could think about these negatives cancelling each other out and leaving our result as positive. However, in this question, you can see that the base number is positive. So essentially what's happening is we're doing 3 times 3, +3 times +3, and we're taking the negative of that answer, right? So the negative being outside the brackets means that the multiplication is all positive, giving us a positive answer, and then including the negative, it would finish up as negative. However, in this question, you can see that the negative is attached to the base, which is being multiplied by itself, and cancelling out, giving us a +9. That's important to remember. And then I guess from there, we can start to think about, well, what happens when we raise it to different powers? So the questions we just saw was raised to the power of 2, and you can see the negatives cancelling out there. If it was raised to the power of 3, you can see these two negatives cancelling out, but then we still have this negative by itself, which would transfer into our solution here. So if you have a negative number raised to the power of 3, you can see that the answer is going to be negative. To the power of 4, well, these two negatives would cancel out, and those two negatives would cancel out, leaving us with a positive result. And raised to the power of 5, I guess those two would cancel out, those two would cancel out, leaving us with 1, and our answer, our solution is also negative. So there's a little bit of a pattern occurring here, and this is the pattern. Negative numbers raised to an even power give us a positive result. Okay, so what we're saying there is even, positive answer, positive answer. Negative numbers raised to an odd power, or odd being odd numbers, give us a negative result. Okay, so you've got like odd, negative, negative. All right, so these are two quite crucial points you might want to write into your notes. And we sort of made that point already. Now we're actually looking at inverse indices, or negative indices. So you can see here that the index is actually raised to the power of -1, not just +1. And we have a index law which tells us that anything raised to a negative index can be written as a fraction with a numerator of 1. Okay, so wherever you see this, and it doesn't have to be the number 8, it could be the number 15 or 9 or whatever it is, you can write this setup just like this. All right, same here. 3 to the power of -1. All right, we've got a base of 3 and a numerator of 1. And like I said, that can happen with any number. All right, so 15 to the power of 3 with a 1 over. Okay, so this setup here is known as inverse. All right, the word inverse essentially just means opposite. So I guess the opposite to the number 15 would be the number 1 over 15. Okay, so by having a negative index, I guess it's turning 15 into the opposite of 15, which is 1 over 15. Now that's really the only bit of information that we need to write. If you like, you can write that in your notes, and you might want to pause this video because you probably won't have a lot of time to do that now. Really, you can write the whole thing. Give a couple of examples as well. All right, so you can throw that into your notes. And then what I'm going to get you to do today is answer Chapter 2C, page 67, questions 1 and 3 to 9. But what I will do is quickly run you through some of these examples because they are quite difficult. I'm just going to pick some random ones. So, okay, I'm expecting you to do all of these questions, but I'm just going to pick some to make your life a little bit easier. All right, so e to the power of -1 can be written 1 over e. Pretty straightforward. We don't necessarily need to put an index because it's just to the power of 1. Question 3, write each fraction. So obviously we've been given fractions in index form using a negative index. So if we had 1 over k, that would be the same as writing k to the power of negative 1. Looking at some other examples, g, so 1 over g to the power of 11. And the question's telling me it should have a positive index. Maybe we can pick another one here to make life easier. 1 over m squared. Now we're sort of doing the opposite. We're going to go from positive to negative index. So for example, this question here, 1 over p to the power of 4 can be written as p to the power of negative 4. Make that a bit more clear that that's p to the power of negative 4. G to the power of negative 11. Now we really start to get much more difficult. And I'm going to try and explain why some of these are the way that they are. The first few you should be pretty easy with. It was pretty similar to the last question. It's when we start to get into these questions where we start to get a bit more difficult. Okay, let's have a look at this. So on top, we have h to the power of negative 4. So if we were just looking at that, that would actually be written 1 over h to the power of negative 4. So you can see that the h to the power of negative 4 is actually being dropped to the bottom of the fraction. So I guess you could really start to think about it like this. Negative 7. All right, but this m to the power of negative 7 was already on the bottom of the fraction. And so I guess we could even put that on the bottom of a fraction again, m to the power of negative 7. So this is all gone now. So because the m to the power of negative 7 was on the bottom of the fraction and it's inverse, I guess you could say it becomes the fraction of a fraction, but this can't actually happen. We can't have two fraction bars in one question. So essentially what happens is we have an unwritten rule in maths. The denominator of a denominator becomes a numerator. All right, so this setup here is going to be pushed to the top because we can't have that. We can just put it up here, m to the power of 7. All right. So essentially what it's saying is whenever you have a fraction with a negative index, you just move the base with the index to the opposite side of the fraction bar. Okay, so like I've done here, I just put the m to the power of 7 on top and the h to the power of 4 on the bottom. All right, so I essentially just swap them because they were both negative. All right, let's look at another example, k. So that was L. Let's look at k. So again, k to the power of negative 6, that's going to be pushed down to the bottom. K to the power of 6, and p to the power of negative 2. Because it's on the bottom and it's negative, it's going to get pushed to the top. P to the power of 2. Let's look at some harder questions like n. Okay, so now, again, bottom of the fraction, negative index, that's going to get pushed to the top. So now it's actually not even a fraction. U to the power of 3 and W to the power of 8. N, O looks pretty straightforward. Q is quite a difficult one. I'm not going to do R because I want you to practice a question this difficult, but I will show you Q. So 6d to the power of negative 5 over 3c to the power of negative 9. So starting here, well, first we can simplify the numbers, all right? 6 divided by 3, that just becomes 2. 2 on top, nothing on the bottom, because we divide that by 3, divide that by 3. Now, d to the power of negative 5, that's going to hit the bottom. D to the power of 5, and 3c to the power of negative 9. Again, it's on the bottom with a negative index. It's going to get pushed to the top, so that's c to the power of 9. All right, so that's Q. I'm going to give you a second to write those down, or you can pause the video when you get a chance and write those down. Some more space so we can start to look at question 7, which is the hardest one I've set. So we're going to need some space to do that. Let's have a look at, I don't know, F, and then we might do H as well. All right, so F is, I'm not going to rewrite it. Okay, so this x to the power of negative 6, well, that's going to be pushed to the bottom of the fraction. and this w to the power of negative 2 is going to be pushed to the bottom, but the 4 is going to stay. Nothing, the 4 didn't change, so we're actually going to have the 4 on top. With these two down the bottom, we're going to write w first because we're going to write it in alphabetical order, and x to the power of 6. Okay, so that's what's going to happen with f. The 4 is going to stay because it doesn't have a negative index. The x to the power of negative 6 and the w to the power of 2, the negative 2, will actually get pushed to the bottom of the fraction. H, k to the power of negative 3, that's going to get pushed to the bottom. M to the power of 5 will stay. N to the power of 8. So that's H. What else do we have? L. Let's try another hard one. All right, 8 divided by 2, we can work out. Divide that by 2, divide that by 2. We're going to be left with 4 on top. C squared is going to stay on top because it's a positive index. D to the power of negative 5. All right, so that's going to get pushed to the bottom. D to the power of 5. And what else? Where was I? E to the power of negative 6. Okay, so on the bottom with a negative index, that's going to get pushed to the top. C, D, E to the power of 6. So that's quite a few questions already. We might do one more. Why not? Let's look at a really hard one. That's about it. We'll try P. We'll just do the real hard one. So 5 divided by 2, we can't simplify that, so the numbers are probably just going to stay. Okay, this is 5 to the power of negative 1, so that's going to push the 5 to the bottom of the fraction. So we sort of dealt with that. X cubed won't change because it's a positive index. K to the power of negative 2, that's going to hit the bottom. K to the power of 2. All right, the 2 is going to stay on the bottom. All right, so the 5 is now on the bottom, but there's also a 2, so we could do, say, 2 times 5. So the 2 dealt with. U to the power of negative 5. So U to the power of 5. I'm trying to put it in alphabetical order here. And W to the power of 8 won't change. Okay, so let's simplify this. U to the power of 5, x cubed over 10, all right, because we'd have 2 times 5 is 10. K squared W to the power of 8, and that's your answer. All right, so that was really the hardest question in 7 that I can see. Is there anything else we need to consider? I think that's about it. All right, so that's a pretty good summary, a few examples. Feel free to watch this video as many times as you need to really have a better understanding on how to answer these questions. Keep coming back to it. You know, if you, by the time you get to question 7, you may have forgot some of these examples. You might struggle with, I don't know, N. All right, you can always come back and watch the video and try and get a bit more of an understanding of why I've made the decisions that I have. Thank you for listening, guys.